This video is on Chapter 11. Chapter 11 covers technology, production, and cost. So we're going to learn what technology is by an economic definition, the short run and long run in economics, the marginal product of labor, the average product of labor, and the relationship between the short run production and short run costs. So let's talk about the definition of technology in an economic setting and give examples of a technology change. So, firms and technology. The basic activity of a firm is to use inputs. And when we think of inputs, it's workers, machines, and natural resources. So we put all these things together to produce outputs, either a good and/or service. We call this process by which a firm does this a technology. So it's not like you're just specifically referencing the iPad. The technology is when a firm puts together workers, machines, and natural resources to produce outputs. So if a firm improves the ability to turn inputs into outputs, we refer to this as a positive technology change. Technology is the process a firm uses to turn inputs into outputs of goods and services. A technology change is the ability of the firm to produce a given level of output with a given quantity of inputs. For example, if I could have produced 5 iPhones for one worker, and I have a technology change, we change maybe a process or something, and now each worker can produce 10, then we have a positive technology change. So Walmart, in your book, there's an example of improving inventory control. One of the ways that firms frequently improve outputs is different process overview and becoming more efficient. We always hear that. How can we do this more efficiently? One of Walmart's important inputs is its inventory. So Walmart invests money to improve management of its inventory by linking cash registers to control computers. So basically, always constantly making sure that inventory is up to date. Improvements in technology can help Walmart be more efficient, turning its inputs, inventory, labor, and a physical store, into outputs, sales of the product. So we're going to talk about what's the difference in an economic short run and an economic long run. So economists refer to short run as a period of time during which at least one of the firm's inputs is fixed. A lot of times we're talking about like the size of the store or the machine or equipment. This is a fixed number. For example, a firm might have a long-term lease on a factory and it is too costly to get out of. So in the short run, we're not going to change that, but in the long run, we might renegotiate or move someplace else. In the long run, no inputs are fixed. So short run, at least one is fixed. It could be more than one. And in the long run, no inputs are fixed. The firm can adopt new technology and increase or decrease the size of its physical plant. So fixed and variable costs. These are very important in business and in economic terms. A variable cost is a cost that changes as output changes, while a fixed cost is a cost that remains the same as output changes. Variable costs are usually like hourly workers, also products that go into manufacturing. If it's directly related to the product, usually variable. But if we purchase a building, that's pretty much a fixed cost, at least in the short run, right? In the long run, all of the firm's costs are variable, since in the long run, there is sufficient time to alter the level of any input. So here's the definition of total cost. Total cost equals fixed cost plus variable cost. While you're listening to this, make sure to write this down. Total cost, TC, equals fixed cost plus variable cost. TC equals FC plus VC. Total cost equals fixed cost plus variable cost. So the academic book publishing turns to its inputs, intellectual property, labor, printing machines, paper, factory electricity, and outputs into books. As it increases the number of books it publishes, some of those inputs stay constant and some rise. Which ones are constant? So I would say paper is variable depending on the number of books. Factory, fixed. Intellectual property. So if you're buying this intellectual property, it doesn't matter if you sell 1 book or 10. Fixed. Labor depends on whether they're salaried or hourly. Salaried employees are a fixed cost, pretty much. And hourly employees only work when there's work to be done. Printing machines, fixed cost. Electricity varies with output. So recall that economists like to consider all of the opportunity costs of an activity. We've talked about this in previous chapters. So we're talking about both explicit costs and implicit costs. The explicit costs of running a firm are relatively easy to identify. Just look at what the firm spends the money on. Explicit, what are we spending money on? Implicit costs are harder to find, involving identifying the resources used by a firm that could have been used for another beneficial purpose. For example, if you own your own firm, you probably spend time working on the firm's activities. Even if you don't quote-unquote pay yourself explicitly, which would be an explicit cost, there's still an opportunity cost. You could have been spending your time doing something else. So economic definition, explicit cost is a cost that involves spending money. An implicit cost is a non-monetary opportunity cost. For example, in your book, we're going to talk about Jill Johnson. She quits her $30,000 a year job to start a pizza store. She uses $50,000 in her savings to buy equipment, furniture, etc., and takes out a loan. So here was what she buys. Pizza dough, tomato sauce, and other ingredients. Total $20,000. This is an explicit cost in red. Wages, $48,000. Interest payments on the loan to buy the ovens, $10,000. Electricity, $6,000. Lease payment for the store, $24,000. The items in blue are implicit costs. So it cost her $30,000 on her salary that she gave up, interest that she would have been making on the $50,000, and economic depreciation. Using these things, so we're going to use these items and they depreciate. So the total cost of opening this pizza shop is $151,000. And economic depreciation is the decrease in the resale value on the things that Jill bought. So, for example, she bought pizza ovens. When she uses them, they're not worth the same amount of money. All of these implicit costs are real costs of Jill owning the pizza, even though they don't require an explicit outlay of money. Many times people forget these costs, and they don't take it into the equation. Notice in particular, Jill is charging herself for the money she took out of her savings. It's just like the bank charges her interest on the loans. Jill Johnson's restaurant turns its inputs, pizza ovens, ingredients, labor, electricity, into pizzas for sale. To make an analysis, let's consider only 2 inputs. So she's got pizza oven and workers. The pizza ovens will be a fixed cost because once you buy the pizza oven, you can't really change it, and this is short run. So we'll assume she can't change the number of pizza ovens. The workers will be variable. We'll assume Jill can easily change the number of workers she can hire. So Jill Johnson's restaurant has a particular technology by which it transforms workers and pizza ovens into pizzas. So at 0 workers and 2 ovens, they make 0 pizzas because there's no one to make pizzas. With 1 worker and 2 ovens, they make 200 pizzas per week. At 2 workers and 2 ovens, you make 450 pizzas. Then we get 3 workers, 2 ovens. Remember, the ovens is fixed. 550. 4 workers, 2 ovens, 600. As the number of workers increase after a certain point, the per worker production goes down. So the total number of pizzas continues to go up, but not by the same amount. So this is, as the number of workers increase, so do the number of pizzas to be produced. This is the firm's production function. It is the relationship that the inputs employed for the maximum output of the firm. Each pizza oven costs $400 per week, and each worker costs $650 per week. So now we're going to figure out the firm's cost. The firm has a total of 800 in fixed costs, and it goes up from $650 per employee. So even at 0 pizzas, there's still a cost to it because we have a total cost for the fixed cost. At 1 worker and 200 pizzas, the ovens cost $800 and the worker costs $650. Total cost per week, $1,450. And it continues to go up from here. So let's graph this. So using the information on the table, they graph the total cost for Jill. Notice that cost is not 0 when quantity is 0, and that's because of the $800 in fixed oven cost. Naturally, as costs increase, Jill wants to make more pizzas. If we divide the total cost of pizzas by the number of pizzas, we get an average total cost per pizza. So this as our total cost. This is the quantity of pizza. So we take this and divide it by this. And then so at one worker, it's our average cost per pizza is $7.25, but it significantly drops when we add a second worker. So $4.67. But then when we add a third worker, it's $5, and it goes up from there all the way to the point where at 6 workers and 2 ovens, it costs us more than 1 worker. For low levels of production, the average cost falls as the number of pizza rises. At high levels, the average cost rises. And that's because we have so many workers and not enough ovens that basically they're just getting in each other's way. So the falling, then rising nature of average total cost results in a U-shaped curve for total cost. So what you want to remember is total cost kind of creates a U-shaped curve. It starts high, goes down low, and then as you increase the number of workers, it starts to go back up. Our next task is to examine why we get this total. So understanding the relationship between marginal product of labor and the average product of labor. So suppose Jill hires 1 worker. What does that worker have to do? Well, 1 worker would have to take orders, make and cook the pizza, take the pizzas to the table, and run the cash register. By hiring another worker, these tasks could be divided up, allowing some specialization to take place, resulting in a division of labor, and more efficient. 2 workers can probably produce more output per worker than 1 worker alone. As you can see, 1 worker can only do 200 pizzas, but 2 can produce 450. To think about it, let's consider the marginal product of labor, the additional output a firm produces as a result of hiring 1 more worker. So this is divided by the number of workers to get here. So quantity of pizzas divided by the number of workers. 0 obviously produces 0. At 1 worker, they can produce 200 marginal product, 200 pizzas. At 2 workers, each of them can produce 250. Adding the second worker produces an extra 250. But then adding the next worker only produces an extra 100 pizzas, and then 50 and 25 and 15. The first worker increases output by 200, the second by 250. And every additional output workers adds to the potential output, but not by as much, eventually starting to get in each other's way, etc., because there's only a fixed number of pizza ovens and cash registers. This is the law of diminishing returns. And at some point, adding more of a variable input to the same amount of fixed input will cause marginal product of variable input to decline. So basically, after this point in the pizza shop, because there's only 2 ovens, each time you add another worker, marginal product goes down. Law of diminishing returns. So they're graphing the total output per pizza and then the marginal per worker. This is continuing to go up and this is starting to go down. When marginal product of labor is decreasing, but it is still positive, total output increases, but at a decreasing rate, basically. Another useful indication of output is the average product of labor. This is calculated by total output produced by a firm divided by the quantity of workers. With 3 workers, the restaurant can produce 550 pizzas, giving the average product of labor 183 pizzas. A useful way to think about the average product of labor is the average of the marginal products of labor. The first 3 workers give 200, 250, and 100 additional pizzas. Add that up and divide by 3, and you get 183.3. With only 2 workers, the average product of labor was 225. So the third worker made an average product of labor go down. This happened because the third worker is less marginal output on average. If the next worker produces more marginal output than the average product will rise. So let's see it. So we have Paul. His GPA starts off poorly, then rises, and then eventually falls his senior year. So he starts off with a 1.5, then he goes to a 2.0, then a 2.2, and then a 3.0, a 3.2, and then he starts to go back down, 3.0, 2.4, and 2.0. His cumulative GPA continues to rise all the way into the point where with his marginal GPA below the average, it starts to bring down the average. You can see right here, it's starting to bring down the average. If it continues to go down, the average will continue to go down. So what's the relationship between short-run production and short-run costs? We have already seen that average total cost equals total cost divided by output. So we can define marginal cost as the change in the firm's total cost for producing one more good or service. Change in Q, or change in quantity, is generally needed because we don't see quantity increasing by only one unit at a time. So a change in Q, so what we have here is quantity of workers, quantity of pizzas, marginal product cost, total product cost. Then we have marginal cost per pizza and average total cost per pizza. We can visualize the average and marginal cost of the production graph. The first two workers increase the average production and cause cost per unit to fall. The next four workers are less productive, resulting in a higher marginal cost. So the first two workers make it fall, and then it goes back up. So make sure we understand that the formula for total cost is variable plus fixed. If we divide these both by quantity, we can obtain a useful relationship. The first quantity is average total cost divided by quantity. The second is average fixed cost divided by quantity. And the third is average variable cost divided by quantity. So average total cost equals average fixed plus average variable cost. When marginal cost is above average total cost, the average total cost is falling. When marginal cost is above average total cost is rising. So what does this mean in a graph form? The result is both average total cost and average variable cost have U-shaped curves. And this is your marginal cost. Average total cost, average variable cost, average fixed cost. Average fixed cost is going to go down because it's fixed, so it's not going to change with output, continuing to go down. So understanding how long-run cost curves. Recall that in the long run is a sufficiently long enough period that everything is variable. So in the long run, there is no distinction between fixed and variable cost. A long-run average cost curve shows the lowest cost at which a firm is able to produce a given quantity of output in the long run, when there are no fixed inputs. At low quantities, a firm might expect economies of scale, the firm's average cost falling. Here's how a small bookstore can produce at a lower average cost than a large bookstore. So at a small bookstore, at average total cost for like a Barnes and Noble. So the firm experienced constant returns to scale. Its long-run average cost remains unchanged as it increases output. And actually, you could get diseconomies of scale, which is where the average total cost actually goes up as you sell 60,000 units. And that's because they might have to hire unskilled workers to work in the factory, or the production is less suited, or they can't manage that many people effectively, and so this causes diseconomies of scale. Henry Ford is well known for his success in producing cars on an assembly line, allowing division of labor to achieve economies of scale. Hoping to build on this, Ford built an enormous industrial complex at the River Road in Dearborn, Michigan, to produce the Model A. The Model A lost money for Ford because the River Road complex was too large to allow efficient production, producing a disconnect between workers and managers, and basically the plant was too big and they couldn't efficiently run it. So here is a summary of cost and definition. Total cost is the cost of all inputs used by a firm, or fixed cost plus variable cost. Fixed costs remain constant as the firm's level of output changes. Variable costs change with the level of output. Marginal costs increase in total cost resulting from the production of another unit. Total cost, average total cost is the total cost divided by the quantity of output produced. Average fixed is fixed divided by quantity, and average variable is variable divided by quantity. An implicit cost is a non-monetary opportunity, and explicit is a cost that involves spending money. Misconceptions to avoid. A technology in economics refers to the process of turning inputs into outputs. Increasing average cost can occur in the short run, diminishing returns, or in the long run, diseconomies of scale. The reasons for the two are not the same. When calculating marginal product of labor and marginal cost, don't forget about the denominator, the bottom line in the equation. This is the most common error in calculating these. And remember, in the long run refers to not a specific time period, but a conceptual period of time that is sufficiently long to allow inputs to be altered. And we're not going to cover the appendix for Chapter 11, so this is it for the Chapter 11 overview.